Hey all, this is a fast guided walkthrough of the 2021 Methods VCE Exam 1 paper. I sat this last year and I know how frustrating question 9 was when I was in the actual exam, and I feel like the exam report, the iTutor report, and the other YouTube video I've seen on this exam don't really have good solutions at all. So I would watch this through the end for question 9 if for nothing else. So let's get started. So basically we're using the chain rule. If you have e to any power, you just find the derivative of that power and you bring it out the front. With this formula, what I like to do is I like to change whatever is under a square root sign into the power of a half, and then you just use the product rule. The power of the first term here, x, the derivative of the first term times the second term plus the first term times the derivative of the second term. And don't forget to use the chain rule of whatever's inside of another function. So the 2x plus 1 here is inside the square root. For this question, we're given the derivative equation. So we need to find the original equation, and we're given the information that f1 equals 2. So basically, we integrate the derivative equation to find the original equation, and we're left with a plus c. And that plus c is important because we have to find it. And then I forgot to plug the c value back in to find for the complete original equation. Here we just have a sine equation, and the range is just going to be the amplitude, which is here is 2, and so the 1, -1 becomes -2, 2, which are included. Periods are 2 pi on n. We have 2 inside the bracket there, so it's pi. Here with these questions, it's important to know whether, because you have sine inverse means you're finding an angle, and since it's a positive angle, we know we're working in the first and second quadrants, which is what a lot of people forget, and usually they just work from the first quadrant. So in this case, when they're finding inverse sine of root 3 on 2, say the angle is pi on 3, they would usually just have pi on 3 as the solution rather than pi on 3 or 2 pi on 3. Here I just give the unit circle as an example of how you need to visualize it being positive, so the first and second quadrant, and then use the 60-30 triangles, the magic triangles, to find out what your side lengths are going to give for an angle. Also, with these questions, since it's this circle, when you have pi on 3, you can go around another 2 pi, and then you arrive at the same point or the same angle technically. So there are infinite solutions, 2 pi multiples that can be going in the negative direction or in the positive direction. And these are integer values of 2 pi, which you need to specify in your answer, because if they were not integer values, it wouldn't actually be 2 pi multiples. And so we say multiples with k, and then we show that k is an integer by saying k is an element of z, which is very important. And you don't have to say that once, you don't have to say that with each line of working out. You don't have to say k is an element of the integers on your first line of working out. The first thing I like to do with these questions is to find the asymptotes. So here we know that the equation is undefined when x equals 2, because you have a denominator of 0, which can't be, so we know an asymptote of 2. Also, we know that as x approaches infinity, y approaches 1. So x approaches infinity, you obviously can't reach infinity, so that gives you an asymptote. And as x approaches infinity, you get 2 divided by an infinitely large number, which equals 0, so we get y equals 1, minus 0, which is 1. And then we find where the axis-intercepts are. So we do x equals 0, y equals 2 here, because we get y equals 1 minus 2 on negative 2, which is y equals 1 plus 1, which is 2. And then we solve for when y equals 0, which I did just there. And when you're drawing the graphs, the most important thing to consider is that you don't draw like multiple lines when you're sketching it. You just draw one smooth line. Otherwise, you'll get marks off for that. And make sure you include your axis intercepts. Here, it's very important you write equals 3 and then do your greater than signs afterwards, because otherwise you'll get confused. Here, it's greater than or equal to 3. It has to be less than the asymptote. So there, it has to be greater than or equals to 3 as the y value. So then I showed what the x value would be for that. It can't be equal to the asymptote, so it has to be less than 2, but it can be equal to 1. So you have to do the square bracket for that. Here you're given the turning point form, so that's going to be 1, negative 4. And we have an axis intercept, so we can use the symmetry property of parabolas to find what the other axis intercept is, which is 0, since it was at 1 and 2. So we know that other points can be 0. The other x values can be 0, or the y value of 0. So the origin. Here we have the graph of h, which is a transformation of f. And with these questions, I like to do the x dash equals and y dash equals method, which I suggest using. It's the easiest method. So here we know that we've rearranged it to find, and then when we sub it into f of x, we know f of x equals x squared minus 4, but it's the x, you have to square everything. X equals 2 multiplied by x dash minus 2. Make sure that whole thing's squared. A lot of people don't square the whole thing, which is how they get marks off. Also, I forgot to put the intercepts in. The intercepts use the same symmetry properties as the previous question, and you know that the dilation factor was 4. With this question, I always like to draw out a probability table, and I like to use numbers instead of probabilities in the probability table, which I think goes without saying. And then you set the whole thing up, and there you go. And whenever you have a probability, you do the likelihood of whatever it is happening over the total event space. Here it's 8 over 20 because there are 20 donuts, and the probability of it not being glazed with custard is 8. I mean, there are, yeah. Okay, so here we have two new boxes, A and B. Each contains 10. G is the number of glazed donuts in box A. So we know the number of glazed donuts in B equals the total number of glazed donuts minus the number of glazed donuts in A. That gives the number of glazed donuts in B. We know that any probability is equal to the number divided by the total number. So we have to find the number of glazed donuts in B over the total number of donuts itself, which is 20. So we know the number of glazed donuts is 6. And we know that G is the number of glazed donuts in A, so 6 minus G is the number of glazed donuts in B. So we have to divide that whole thing by 20 to get the probability of it being glazed and in B. Yeah, do not use 10, which is the total number of glazed donuts in B. We want the total number of donuts. Here we set up another probability table. Again, don't use probabilities, use actual numbers. So there's 10 in A, 10 in B, total 20. We know there's 6 minus G in G intersection B. And that's all we need to solve the question, because all we need is G and G and B. So we get probability of B and G over probability of G. And so it's going to be 6 minus G over 20 divided by 6 on 20. So then we multiply by the inverse to divide when there's big divisions like that. So we get 6 minus G on 6. Alright, here so we have over 1 million visitors. That obviously already tells you it's binomial. P p hat is equal to x on n. We know this. And we have to define the variable x we're going to use. So the sample space is 5 and the probability of success is half. So we go from probability of p hat is greater than or 0 equals 0.8. We sub in p hat for x on 5, and then we multiply the 5 out, so we get probability x is greater than or equal to 4. We know that the sample space is 5, so probability x is greater than or equals 4 equals probability x equals 4 plus probability x equals 5, because you can't go above 5. 5 choose 4 is 5, because there's 5 slots, only 4 places. 5 choose 5 is 1, because there's 5 slots, 5 places to fill. And then we just multiply all that out, and then we simplify to 316. So here we have a probability density function. That means that the integral of f of x over the domain is equal to 1, which is very important. Always write that down whenever you get a probability density function. We also know that k is a constant, so we can take it out the front of the integral, which is also very important to simplify everything down. Make sure you do the power rule properly for the integral, where you add 1 and put it over, and we get k equals 2. The expected value of x equals the integral, where x times f of x is in the integral over the domain, and we found what k was, which gives us what the new value of f of x is equal to, and we use that to solve the integral now of the expected value of x, which is pretty straightforward. So we have the natural log of 2 minus natural log of 1. The natural log of 1 is always equal to 0, so we just get the natural log of 2 times the natural log of 2, and then we can bring the 2 up to the power because of this log law. Therefore we get the natural log of 2 to the power of 2, which equals natural log of 4. Alright, here we're given an x value and a y value, which is important, and we also know that that x value is at a stationary point, which is also important, but for now we're just using that it's an x and y value. So we're given the derivative equation, and so we use the integral of the derivative equation to find the original equation, or f of x, and we know it's going to be a plus c value in there, and then we solve for the plus c using the x and y values. So we go f of 3 to solve for it. And then we go through that. Here is where a lot of people get stuck. You have a square root and then a 9 cubed. Or we have 3, you have to the power of 3 on 2. We know that to the power of a half is a square root. That means the power of 3 on 2 must be square root, and then the inside term is cubed. And so we know that the square root of 9 is 3. 3 cubed equals 27. And then from there you just simplify using arithmetic, but you have fractions, so make sure all your fractions have the same denominator when you're adding and subtracting. And this is me going through my arithmetic. Yeah, so I'm doing that to get the same denominator of 12, which should be negative 4. Negative 48 on 12 equals negative 4, yep. And now you have to write out the whole rule of the function, which is what you found before, but you had plus c. Now you know what c is, so you just sub in what c is equal to negative 4. Here's 2 common methods that are used in methods to find the nature of a stationary point. There's the first method, which uses the double derivative. If the double derivative is negative, you know you have a maximum. If the double derivative is positive, it means you have a minimum turning point. So we just find the derivative of the derivative equation to find the double derivative equation, and then we sub in x for the double derivative equation, and if we find out f dash dash of 3 is negative, that means it's maximum. If we so it's less than 0, that means it's negative. It means it's a maximum turning point. Method 2, which is the one I used in the exam, it's faster in my opinion, and it means you don't have to remember that you don't have to remember as much, and you can visualize it a lot easier. So we had x equals 3, and we knew that that's a stationary point, so the slope is 0. And then I used -2 because then you get the square root of 4. So I used x values to give me a square term under the square root. So here we have 2 plus 1 minus around 2. 2 plus 1 is 3 minus around 2. That's greater than 0. So you have a positive derivative, and that means a positive slope going upwards. Next we use 10 because that gives us the square root of 16, which is 4. And then we get -5 minus 3 on 2. So that's going to be negative. So we get a negative slope. So the slope is increasing. It's 0, then it's decreasing. That means it's a max turning point. Now we're up to question 9. Obviously the hardest question in the exam, and this one requires a lot of visualization skills, which is where you need to practice your visualization questions from previous exams to get good at them. Here we need to know that m equals tan theta. Theta is the angle from the origin, so let theta equal the angle between A, the origin, and point P, which is the nomenclature for it there. We know from origin to A is 2, and we know from origin to P is 1 because it's a unit circle, and it says x squared plus y squared equals 1, and therefore we know the radius equals 1. So we know that m equals tan theta, so we know that we could already say that tan theta equals √3 because we already know that, but here I'm proving that by just doing a proof that shows you both ways give you the same answer, really. Okay, so we know the grade from OP is √3. We already knew that because it was tan and you had √3 over 1. We know that P to A, the line P to A is perpendicular to O to P, so it's going to be the negative inverse of the gradient, so it's -1 on √3. And now we know the equation of AP, or PA, is y equals the gradient times x plus c. So we know the gradient's -1 on √3, and now we also know that A, which is on the line PA, has points x equals 2, y equals 0, because it's A is 2, 0. And we just sub that in to find what c equals equal to. C equals 2 on √3, and now we just rewrite it out. It's good to clear your workings out from previous questions so you can include all the information you want for the next question. Q here is multiplying by y, therefore it's a dilation from the x-axis because it's making the y values bigger or smaller. We know that A, you can think of this as a fulcrum point, because if the y values are getting bigger or smaller, you're multiplying the y values, and anything you multiply by 0 is equal to 0, so that's not going to change. That's the only point in your graph that's not going to change when it's dilated. So you can kind of think of the line as like a lever, and you have A as a fulcrum, or a point that doesn't change. So that line is for Q equals 1, obviously, because there's no dilation. So as Q increases, those y values can get bigger, so that's going up. And as Q increases right of the fulcrum, the y value is going to decrease, or could become more negative, and the opposite as Q decreases. So if it must intersect the circle at least once, that means it touches it. So you'd write you draw another line, which I've done in red, and yeah, so if Q is higher than 1, it's not going to intersect at all. And if Q is less than -1, as I'll write in a second, then it also won't intersect. Now we know that the red line is an exact reflection in the x-axis, because look at point P and then think of that the same x value but negative, that's where you get the red line intersecting with the circle. Therefore, we know pretty much it's an exact reflection, because same x value but the y value negative gives you the other intersection point. Therefore, we know if it's an exact reflection of the x value, then we dilate it by -1. So q is -1. Gives you that red line. And so if q is less than -1, then it won't touch the circle at all because it'll go too low. Also, here I did not include the domain of q, where q does not include 0. So make sure you include that. I forgot to when I was going through it when I was going through the exam. Okay, so for question BII, we are trying to find a new line h of x, and we want h of x to intersect this circle twice, but we want both points of intersection to only include positive values of intersection. That means the x values of the points of intersection have to be positive and the y values to be positive. That only happens in quadrant 1. Now our original line, which is this black line, intersects only once. So that means, and that happens at q equals 1. So q equals 1 is an upper bound, but it's not included. So it's going to be a circle bracket, around a bracket, sorry. And we know this red line, right, where it intersects at 0, 1, that value of 0 for the x value is actually not positive, because 0 is not positive. So that's going to be a lower bound where it's not included, right? So we have the upper bound, which is the red line, and we have the lower bound, sorry, the upper bound, which is the black line, and the lower bound, which is the red line. And we know that q equals 0 is just going to be a line that goes through the origin from A. So that's obviously not right. So that means the red line is going to have q is greater than 0, but it's going to be less than 1. Okay? So we need to find we need to find how we dilate the black line to reach the red line. Now we know if we wanted to make a y value of 1 equal 2, we have to dilate that by a factor of 2, right? And so the new value is 2, the original value is 1, so you do what the new value is divided by what the original value is. That gives you what the dilation factor is, right? Which is what I was saying here. So here I'm multiplying by the inverse to show division of a big thing. So here we have the new divided by the old, which is how you find the dilation factor. So we have the y-intercept of 1 divided by the y-intercept of 2 on root 3, or times root 3 on 2. That shows what the dilation factor is, which is root 3 on 2. And then I'm showing you that you can also find the dilation factor of the gradient to find the dilation factor of the whole line as well. So we know the new gradient, so the gradient of the red line is, we have 0, 1, and we have 2, 0, which is point A. So we have the rise of -1 over the run of 2. So -half is the new gradient, right? So we have -half, which is the new gradient, times the inverse of the other gradient, which was -1 on root 3. So we multiply by root 3 on 1, which is the inverse, which is also equal to root 3 on 2, which shows that the dilation factor is root 3 on 2. Again, to find the dilation factor, you do what the new thing is. So the red line, the new y-intercept was 1. You divide that by the old thing. So the old y-intercept was 2 on root 3. And you can divide by multiplying by the inverse. Okay? And so both ways we found a dilation factor of root 3 on 2. So we have what the dilation factor was, q for the lower bound, which is not included, and we have 1, which was the original line. All right, now we have q is greater than 0, and less than or equal to 1. So that's going to restrict our domain of Q, obviously. So that's going to restrict another domain, which we need to keep in mind, because otherwise it'd be pointless putting it there. We know that P dash, which is that line of intersection on the graph, is always the one that's closest to A, not because it's going to intersect the graph twice, and so we're focusing on P dash being the first intersection point. Okay, that's the information we have at the moment. So it's saying let G be the function for the area of the graph, right? Now, what we have is theta, and we have two lengths. We have from the origin to A, which is 2, and we have from the origin to P, which is 1. And we knew that from the start of the question because it's a unit circle, right? So we use the area equals half AB sine theta, and we know that the side lengths in A equals half AB sine theta are the ones that are not opposite theta, so 1 and 2. And then we get G of theta equals sine theta. Now don't write G of x equals sine of x, because this is in terms of theta, not in terms of x. Don't write G of x equals sine of x, or G of x equals sine theta. You get marks off. Very important that you do that, because your area G is determined by theta, because the equation is A equals half AB sine theta, not A equals half AB sine x. So now I'm showing you what happens when you dilate. So with Q equals 0, you get no area. Q is greater than 1 gives you a bigger area, because it the point moves up and to the left on the unit circle, gets closer towards 0, 1, so which would give you a bigger triangle, which would be a bigger area of the triangle. And so we know that it's getting bigger as you move up and to the left, and since it's between 0 and 1, Q is between 0 and 1, we know that 1 gives max area, because anything bigger than 1 would be a greater area, but it goes from 0 to 1. So in Q equals 1, we know when Q equals 1, theta equals pi on 3 from the previous question, before I described the previous question where we found what theta was when Q equals 1, because Q equals 1 was the line we had straight from the start, from part A of question 9. And if that was too quick, you can go over that again quickly. Yeah, so basically we're finding what the area was when we have pi on 3, because pi on 3 gives you when Q equals 1, because we know Q equals 1 gives maximum area, and when Q equals 1, theta equals pi on 3. So now we're just putting in pi on 3 into the equation for G. So we get root 3 on 2, because sine of pi on 3 equals root 3 on 2, as I showed with the magic triangles. You write square units because it's an area. And now I'm going back and I'm putting in what the theta domain is, what the angle domain is, what the theta domain is, because we know what the Q domain is, and we know what the values of theta are when Q equals when Q equals its max and min values in correspondence to the domain. And that's the end of the exam. So yeah, make sure you get really good at the visualization questions. If I was going too fast or any questions, make sure you go over them a few times. Yeah, and really practice thinking about how points move when you dilate them. And yeah, stay calm in your exam.